Chapter 7, Part 2, Day 2. Looking, again, I know I basically described this entire section of the chapter already, so hopefully this makes sense as we go through it, since we've already discussed all these concepts before. So it says, when two events occur, either simultaneously or one after the other, how can you calculate the probability of one of them occurring when you already know that the other has happened? You will investigate this question today. Then you will use conditional probabilities to determine if two events are independent of each other. So, again, we've already talked about conditional probability, and we've already talked about if things are independent or associated or not. So, some more review of that. Marabella is playing the board game Ate the Hard Way with her friends. Each player rolls 2 dice on his or her turn and moves according to the sum of the dice. However, if a player rolls 2 fours, called Ate the Hard Way, that player instantly wins the round and a new round is started. Delaney steps into the kitchen and gets snacks when she hears Marabelle shout, "Woohoo, I got an 8." Delaney knows Marabelle rolled a sum of 8. With your team, help Delaney investigate the probability that Marabelle rolled 2 fours and won the round of play. In other words, calculate the conditional probability that Marabelle rolled 2 fours, given that you know she rolled a sum of 8. So make a diagram to represent all the possible sums of numbers when rolling 2 dice. So I kind of went to the internet and got that, so you can see the first dice is 1 through 6, the second die is 1 through 6, and if you get 2 6s, you get a 12. If you get a 3 and then a 2, you get a 5. So that's A. It says, since you know Marabelle rolled the sum of 8, you do not need to consider all the outcomes in the sample space. You only need to consider the outcomes with the sum of 8. In your diagram, highlight all the ways the sum of 8 can be rolled. How many different ways can you roll an 8? Well, there's 1, 2, 3, 4, 5, right? You can roll a 2 and a 6, a 3 and a 5, a 4 and a 4, a 5 and a 3, or a 6 and a 2. Those are the 5 different ways that you can do it. You're interested in the event Ate the Hard Way. How many different ways can 2 fours be rolled? Well, it looks like there's only one way right there that you can roll 2 fours, right? So, if there are 5 ways of rolling an 8 and 1 way of rolling a hard 4, the conditional probability must be 1 in 5. Again, think about it. We don't care about the 2, the 3s, the 4s, the 5s, 6, 7s, the 9s, 10s, 11s, or 12s. We only care about these 5 results. We already knew they had an 8. So why would I calculate the odds on any of the other ones? So there's a 1 in 5 chance that she rolled an 8 the hard way. It says Becca rolls high, meaning she rolls a sum of 9 or more. What's the conditional probability that a roll is also an odd number? So again, we only care about the 9s, 10s, 11s, and 12s. She rolled high. We don't care about the 2 through 8. So how many of these? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ways. And there's 4, 6 of them are odd. So we would say there's a 6 in 10 chance of that conditional probability. All right, let me set up the rest of this video. All right, it says at Einstein High School, EHS, data on members of Students' Council was collected. So this type of table is called the two-way table and is often used to organize information and calculate probabilities. Obviously, we've dealt with these quite a bit in Integrated 1 and already in Integrated 2. So what's the probability that a student being on the Student Council of EHS? So let's go ahead and get the totals here. So I'm going to do totals here and here. So that's going to be 36, that's going to be 204, 240, 40, and 200. So what's the probability of someone on the student council? It looks like it's 40 out of 240. 40 kids out of 240 are on the student council. It says copy the table and shade the cells with students who eat at the cafeteria. Okay, so these kids eat at the cafeteria. What's the conditional probability of a student being on the student council? I would say 6 out of 36. It says 2 events A and B are independent if knowing that event B occurred does not change the probability of A occurred. And we already talked about associations a bit, right? So independence is just another way of talking about association. Independent means not associated. Dependent means associated. So it says that is two events A and B are independent if the probability of A given B equals the probability of A. Are the events on student council and each cafeteria independent or not? So here's what we'd say. We have a 1 in 6 chance here, and we have a 1 in 6 chance here, so they're both 16%, right? 16% of chance of everybody being on the student council, and there's a 16% chance of if you eat at the cafeteria that you're on the student council. So we'd say there's no association. All right, these numbers are the same. And again, that also means independent because those numbers don't change. It says two events are mutually exclusive if they cannot both occur at the same time. That is, two events are mutually exclusive if the probability is 0. So are the events being on the student council and eating in the cafeteria mutually exclusive? So what we would have to say here is, if I look, here's the people on the student council, and here's the people that eat at the cafeteria. Where they overlap right here would have to be 0, but it's actually 6. So I would say no, they're not mutually exclusive because 6 people do both. All right, so let's go ahead and look at 769. It says the following data was collected about students in Mr. Rexinger's high school statistics class. So again, we can have our totals here of 14 and 18 and 12 and 20 and 32. So hopefully we're all okay with those totals. Now it says he's playing a game with students. He randomly chooses a mystery student from the class roster. If the player guesses the hair length of the mystery student correctly, the player gets an early lunch pass. Madeline's the next player to have the greatest chance of winning should she guess the student has long hair. Well, let's take a look. 14 people have long hair. 18 people don't have long hair. So if she wants to win, there's a better chance he's going to choose someone that doesn't have long hair, right? So she should guess no long hair because the odds would be better. All right, it says Mr. Rexinger tells Madeline that the mystery student is wearing jeans. Okay, so we know that this person is wearing jeans. Now what should she guess? Well, now she should guess long hair because more people wearing jeans have long hair than don't have long hair. So that condition of wearing jeans affects the probability, right? So yeah, her guess should change to having long hair now. It says in a previous course, you may have studied the association of two numerical variables by analyzing scatter plots and least squared regression lines. So we did that in integrated 1. Associations between categorized events, like having long hair and wearing jeans, are determined by independence. If two events are independent, then they are not associated. So we already kind of talked about that up here, right? If two events are independent, then they're not associated, which means if two events are dependent, then they are associated. So are the events not having long hair and wearing jeans associated? So let's take a look. So first of all, again, I'm going to ask everybody, and it doesn't matter which I ask. I can either ask everybody, do you have not long hair, or are you wearing jeans? But then the other is going to become my given. So the first thing is I'll ask everyone, what are the odds of you not having long hair? How many people don't have long hair? And the answer is 18 out of 32. So 18 out of 32 is going to give me, this didn't turn on, 56%. Okay, now I want to check to see if people are wearing jeans. So now I'm going to just ask these people, hey, do you not have long hair? And the answer is 5 out of 12. So if I divide those, I get 41%. So you can see the numbers are different. So I'd say there is an association. Yes, association. Those numbers are different. So for whatever reason, wearing jeans seems to help determine whether or not you have long hair or not. Now, are these events mutually exclusive? I would say no, right? Because there is 5 people that are wearing jeans that don't have long hair, and the answer would have to be 0 for it to be mutually exclusive. Don't forget, mutually exclusive means 0, that it can't happen. All right, let me go ahead and put up the rest of this video. All right, so it says Digital Technical Institute. The following data was collected. Here's how many people are in the Honor Society, not in the Honor Society, academic probation, not in academic probation. Again, it's nice to have totals here, so I will go ahead and total these out. That's 240. This is 210. And this is 30. Would have been nice if they left me a little more room here, but that's okay. So it says, are the events on academic probation and member of the Honor Society associated? So I'll ask everyone, hey, are you on academic probation? And I get 40 out of 240, which is 1/6, so that's 16%, about 16.6. Now I'll just ask the people, it'll say, hey, I'm going to assume you're on the Honor Society. I am only asking people on the Honor Society, are you on academic probation? And I get 0 out of 30 for 0%. So I would say yes, there's definitely an association here. If you're on the Honor Society, that pretty much means you're not on academic probation. Now it says, are the events on academic probation and a member of the Honor Society mutually exclusive? And I would say yes, they are. It can't happen. The answer is 0, right? So anytime that 2 things happening, the odds of 2 things happening are 0, that means they're mutually exclusive. And again, there's no one that is both on academic probation and a member of the Honor Society.